Please welcome everybody to our special edition of the Gartner review meeting. As you can see, today we will look at the results of the hackathon, Hack the Garden, that happened last week. This is also why we have a longer slot today, because there were a lot of topics that we can discuss. Unfortunately, we won't have enough time to go into all the details for all the topics, so each topic is time boxed to only 5 minutes, so that we don't exceed the 90 minutes that we have reserved for today. I won't read out the agenda because it's just too long. You can see it here. You can also find it in the meeting invitation. If you want to take a deeper look at what happened at the respective topics, then you can also go to this repository in the Gartner community org hackathon, and you will find in the list of events links to the summaries for all the events, and the last one is from the past week, where you then can send to the respective topic that you want to dive into. Okay, then let's also try to refrain from asking questions to not go over time. We can ask them later in the chat or via Slack. And with this, I think we can start with the first topic presented by Axel. Start with the OpenVPN.
Okay, I'll share my screen. Can you see it? Is it the correct one? Yes, I think so.
Yep.
The first topic was try to replace OpenVPN with Wireguard. I was busy with this topic together with Stefan, the whole hackathon. The motivation was currently we use OpenVPN as VPN solution for the communication between shoot and seed. And we use OpenVPN with TCP, and so that we have TCP in TCP, which has some drawbacks concerning stability and resilience. And OpenVPN is already quite old solution. Wireguard is a newer solution. We want to use UDP so that the stack gets more resilient to problems. And we want to use this Wireguard multiplexer here to dispatch the Wireguard packets to the seeds. Code-wise, we don't have any PRs, but we have pushed our changes to branches. We have Gartner changes, we have VPN changes, and we have made changes to this multiplexer, but it's only putting the code into a container so that we can deploy it. So we started with this, drawing this picture. We have the shoots on this side. We have the VPN client. This VPN client will now use a WireGuard Go implementation. We have a WireGuard secret with a private key and a public key. The public key is the own key, and the private key is the own key, and the public key is the key of the server. On the seed side, we also have the WireGuard implementation and the WireGuard and the VPN pod. This time the secrets is the other way around. Private key is the own key and public key from the client. And then in the Istio Ingress gateway, we add an additional container, the WireGuard, this multi-WireGuard proxy that should dispatch the traffic to the shoots. We use the same service. The service gets a new port, and the traffic from this port is forwarded to the WireGuard proxy. So let's see it in the shoot, in the local setup. Here is the local setup. On this side, you see the pods in the seed, and the other side, you see the pods in the shoot. What I can show is the Istio Ingress gateway now has two containers, the Istio proxy and the Wireguard multiplexer. And well, I can also show you the secrets. Here you have a new secret. Later we can probably remove the old secrets for OpenVPN. We just kept them here. But in this secret, you can see now that we have a configuration that consists of the private key of the seed and the public key of the shoots. So we have a private key for the seed server and public key of the shoot, and we have the destination here. That is the VPN service, seed server service. Yeah, and yeah, this Wireguard multiplexer needs this information to decrypt the handshake and is able to dispatch the packets then to the correct seed server pod. Yeah, it's working. I can see the logs. Now you can just see here the keeper lives and the VPN shoot. I can see the logs in the Wireguard multiplexer. So here you can see that a connection is initiated, and you see stage 1, stage 2. You see the address of the VPN seed server service. Yeah, I think this is just a local setup. The VPN functionality. If it really works, we need to check it in the extension setup, but it seems to be promising. There's a lot of work to do to make it into the product, but I think it's promising, and we should continue to work on it. I think that's all from my side.
Cool. Thanks, Axel. Then let's directly jump to the next topic, make garden operator single node ready, presented by Andreas.
So Eric, Schubert, and I, we basically took on the task to make garden operator, let's say, less resource exhaustive, because we want to run it on a single node bare metal cluster where the resources we have are finite, especially when it comes to storage. Prior to this workshop, there was actually some work has been done already and address that, because we have, let's say, an extra challenge. This single node cluster is IPv6 only, which actually brought some additional challenges to it. So what happened is basically there was a pod affinity, let's say, hard-coded thingy in the extensions, GCP and OpenStack primarily, which were important for us, which have been dropped, which allowed us to set up even in a two-replica deployment on a single pod, a setup where the extension becomes ready. There was a fix provided by Damian to the Fluent operator where it could not run on Fluent on IPv6 only clusters. So this has been merged but not released yet in the Fluent operator. Then we had to fix Wali because Wali doesn't come up in a cluster where you only have IPv6. The problem here was the fix is actually pretty trivial. I can get this change out of the way. Wali actually doesn't listen for IPv6 addresses in your pod. So if you have no network interfaces with IPv4, it just crashes. It doesn't come up. The problem actually lies in Cortex, which we fixed and basically built a Wali forked version, basically replacing the stuff and also releasing 2 Docker images in a fork. Contributing this upstream will be tricky because this Cortex version is over 5 years old, and bumping into a new one will be hard. So it's kind of a, let's say, a mitigation problem which we kind of solve right now, which makes us basically able to deploy it on an IPv6 cluster, but it's not, of course, the final solution. And then the last part was actually making the Gardener operator itself a bit more flexible when it comes to the Prometheus setup. And for that, we created a pull request addressing this problem. So the issue here is the following. I listed the PVCs here, the Gardener operator and the Gardener are creating on basically your runtime cluster. And you see here, those storage PVC sizes are kind of hard-coded at the moment. And imagine you have a 500 gig, let's say, hard disk in your server. Again, you cannot expand it. This will potentially lead to a problem. So our idea was basically we extended now the component config of the operator, where you now have the possibility for the Garden and the Garden.let deployer reconciler to provide configuration, basically modifying what should go into those. So those values you see here are the defaults in the code, which were hard-coded. If you leave this config out, nothing will change. Basically, Garden operator will do its thing. We added also an optional class, storage class field, which wasn't there before. And we also added validation to this, which was also not available previously for the monitoring part. That's basically it. Next steps is we are basically testing this out in a local environment, but also want to run this on a, let's say, real server and see if that basically suffices our needs. That's basically it. So feel free to comment on that if that's the right approach, or if you have some objections how to do that. Yeah, that's basically it from our side.
Okay, thanks for sharing. So Raphael just informed me that he had to drop for another meeting. So next up there would be Nikki with the OpenTelemetry transport for shoot metrics.
Yep, let me share my screen. Right. So the goal here was to spend some time and effort in a focused way to pursue the interesting idea of getting all our metric signals originating from the shoot via OpenTelemetry ecosystem. And why we're looking in that direction basically is a result of the whole Observability 2.0 initiative in Gardener, where we want to transition our current observability signals towards a common open standards like OpenTelemetry and vendor agnostic protocol like OTLP, and leverage all the community driven ecosystem of OpenTelemetry. So long story short, we already have a pretty good way or idea what to do with logging part. It's part of GAP 34, which is already published if somebody wants to take a look at. But now we are looking into the metrics, and the goal of the hackathon was to see whether we can anyway right now fetch a bunch of exporters which are running on the shoot nodes, including not only these exporters that we deploy, but we also fetch the kubelet metrics and CAdvisor metrics today, and we use a Prometheus pool-based mechanism to actually go and transport these metrics to the Prometheus instance running in the assured control plane. And this is like, as you can see, this is a provider local scenario, and this is the Prometheus web interface for these metrics. The problem with the current approach is that these metrics, they are scraped via a proxy endpoint of the Kube API server. So from one side, we are utilizing unnecessary the Kube API server resources. And from the other side, if for whatever reason the proxy endpoints or the Kube API server itself is in trouble, then we are going to lose a bit of telemetry data. And but this is the current state, and nothing much that we can do about it. But that's why we started to look into, okay, whether we can actually fetch the same metric data via OpenTelemetry collector and push into the same or other Prometheus-based backend, or to be more precise, in OTLP-based backend, which Prometheus version 3 happened to support. And this is the results of the same metrics, as you can see, but then pushed towards an OTLP endpoint, which just happens to be the Prometheus 3 instance. And for example, here is the a quick show of the entire configuration bits without going into much details. So if you want to get a push-based OTLP endpoint or receiver on the Prometheus side, we just need to enable a configuration. The Prometheus configuration itself is in this case is quite empty, so nothing much to be shared here. And if you look into the OpenTelemetry collector, it has a pipeline from a receiver, which is a Prometheus-based component, then a bunch of batching and resource enhancement plugins are fed into the collection of the metrics stream. And then we have a standard OTLP-based exporter, which is a Prometheus one. So anything that can receive OTLP-based metrics can serve as an exporter endpoint. And here, the idea is that these components or backends, which holds our telemetry data or observability data, are not subject to a single vendor or opinionated, so to say, component, but that can be exchanged. So we know that some of our other non-SAP installations are using other backends to store observability data. And if these are OTLP enabled, then we can easily use those. And if you look into the definition of the receiving part, so the collector which scrapes the these endpoints today, there is nothing fancy or strange about it. So it's even a bit more simpler than our configurations today, because we are avoiding this Kube API proxy endpoint there. But this is a standard Prometheus configurations, like okay, fetch all the nodes, fetch the metrics endpoints of the kubelets, basically, and so on and so on. And then we apply the same filtering and relabeling techniques that we use today. And basically we can mimic the same, or not, but reproduce the same labels. One immediate, how to say, show off of when you start to dealing with OpenTelemetry is the labeling formats. For example, our current labels, they does not follow, or they have a opinionated labeling format, like pod, namespace, container, whatever. But if we go and jump into the OpenTelemetry ecosystems, because of the semantic conventions introduced as specifications in the OpenTelemetry, then we have a prescription actually how these labels shall be named. And that is particularly important if we have to transport this observability data across domains. So the common transport protocol and data formats, of course, are mandatory to do so. So we also play around of getting, if we look quickly into the configuration, so there is a very simple OpenTelemetry collector configuration for fetching, again, the same pipeline, so receiver, processor, exporter, but this time the receiver is just a plain Kubernetes event receiver, which is a component or plugin in OpenTelemetry, which is able to fetch Kubernetes events from the Kube API server and then transport them again to any backend which is OTLP enabled. So very simple case. And here is an example how this is for example, Victoria Works backend, which shows these Kubernetes events, which are produced currently from the provider local scenario. So the whole idea of converging observability data upon common standards is look very promising. We are in the pipeline for logging, and now we are exploring also the metrics. As the immediate next steps, what will follow up is probably I'll publish a blog post about these findings, and we'll consider how to proceed later with the whole story, because this push versus pull mechanism needs a bit more thought. But since we are in the beginning of the entire transition or story, I encourage everybody from the community to get in contact with us so we can cooperate on this whole topic. And yeah, with this, I end up here. And as I said, we are just starting, so more than welcome to join all the efforts.
Yeah, thank you very much for that. Also, just as a reminder, let's try to keep it within the 5 minutes. We're still in time, but as a reminder. Next up, there is cluster network observability from Jeremy. I think you're currently still on mute, maybe. At least I cannot hear you.
Apologies for that. How's now?
Okay.
How's it now?
Now it's working.
All right. So we worked on a pull request for a non-Gardener tool called Retina, which is developed by Microsoft. Let me just quickly show you. This initially started with for us, this involvement started with a discussion Johannes had at KubeCon with the developers from Microsoft to add availability zones as labels to the metrics that this Retina tool exposes. And the Retina tool can be used to track network traffic between pods, and now also with this zone information added. So we created a pull request on that. Maybe a quick demo. So we have a Gardener local setup here with 3 nodes, and you can see that I've started an Alpine pod, or 2 Alpine pods, one on 2 different nodes. And there are a couple of Retina agents running in this cluster. And we've configured this metric configuration CRD that Retina uses to also include our new zone label. So what we've done in the Alpine pods is we've started a server using Netcat, and we can send data on here, and it'll show up on the other Alpine pod. And we can also send data from this direction just to have some test cross availability zone data. And in our Prometheus, we scrape some advanced network metrics from Retina between these pods, and we can see that on these pods we get these labels that are the destination and the source zone labels. Actually, I'm seeing the destination label isn't showing up, so this is the demo effect. Sometimes there's a race condition with the caches getting populated. But you can see that ideally, it looks like something more like the screenshot that I've, oops, okay, I need to reload this page too, that I've shared on the pull request, where you can see that there's a destination zone here and a source zone on these metrics. How to proceed with that? Well, we're going to get this pull request merged once we get take care of all the loose ends, and then we can see if we want to contribute this to Gardener maybe as an extension or directly in Gardener. Right, and that's it from our side.
Nice, thank you very much.
Oh, just to credit my co-authors, it's Johannes and Radoslav, who were a great help. So mention that.
Nice, thank you. So next up, we have signing of managed resource secrets that I will present. I've done that with Validity. And let me share my screen. I have a small demo setup. Okay, so what we identified is that until now, managed resource secrets are used as is by the Gardener Resource Manager. And if we look, for example, for the Gardener Resource Manager in the seed, we see that it also reconciles resources from the who can guess it, like the seed namespace. And when we look at the rights that this one has, we see that it has basically can do all rights, permissions to do stuff. So what this basically means is when I'm in my shoot namespace now on the seed, and I see those resources, these managed resources, for example, the managed resource is the TLS secrets, and I just have access to that or secrets in that. That means I could basically, as of now, deploy resources that I want with all of those rights. But for that, I need to get into the seed. And what that basically means now is we use a signature algorithm now to sign those secrets, and those get validated by the DRM. So if we, for example, look at one of those secrets, we see, okay, we have some signature here now, and when I try to edit this resource now to something else, so let's say I have a resource called other resource, so the secret I created earlier. So when we can see that more quickly. We see that we basically have this. This is some random data, and I just copied the signature. And if we now look at the managed resource, we see that the signature verification failed for the secret because the content is not equal. I can also try to basically edit the secret and remove this annotation, and that basically results in there's no annotation, so I will not deploy that. And that's basically it. So what the signature, so the signing key is stored in the Gardener namespace of the respective cluster where the Gardener namespace, sorry, of the respective cluster where it's running. I forgot how we called it, but it is definitely there. And that's basically it for the demo. So for follow-up, there's still stuff that we need to clean up, especially testing, for example, and ensure that the access secrets of the access of the components that create managed resources have access to this to the secret that they can then also sign those secrets. That was everything from my side. And next up, there is Gerrit with Migrate ControlPlane reconciliation of provider extension to managed resources.
Yep, thanks. Let me try to share the screen. Come on. I lately have issues with my screen sharing, and I think I have no luck today.
Okay, so should we?
No.
Oh, it works now.
Now it works. Okay, we just need to be patient, and then it will magically work. So I think this is more like a technical dev topic that Konstantinos discovered before the hackathon. I worked together with him on this one, and we already raised a pull request for that. So yeah, basically figured out that yeah, the control plane components in the seeds, they are still directly applied through the chart applier, the Helm chart applier, and not wrapped inside the managed resource, which is what we usually do for all these components that we deploy. And yeah, the idea was to yeah, also add these managed resources for the seed through into the control plane actuator. And yeah, this is what we did. And unfortunately, the local lab does not have a yeah, seed control plane components. So there are no charts for that. But yeah, for short demo, I yeah, just added an Nginx into the seed. And so there are basically 3 new yeah, managed resources which will appear after this gets merged. And so let's list the managed resources. So this one was not there before. It's also a bit younger. Yeah, and this now just deploys an Nginx to the seed. So for yeah, local extension, maybe you don't see any difference, but for the provider extensions, you can make use of it. And this has some advantages over the Helm chart approach or the applier approach, because yeah, this does not really persist the state of the deployment. And when you just as an operator remove something from the chart, then yeah, it cannot remove it properly and stuff like that. And this will be resolved with this small change. Yeah. And during the work on this one, yeah, I also came across another topic, which was the values provider interface, which we have in the control plane controller. And this is where I created an issue and asked for feedback, but nobody replied. So maybe it's not so interesting for you guys, but it's about yeah, this interface in the control plane actuator where you have to like return the Helm values to parameterize the Helm charts for the control plane. And newer extensions already just deploy managed resources using the Golang Kubernetes API and create objects there. And the idea was to implement like an alternative interface where you can just return client objects directly to the generic actuator and not use Helm charts at all. So I think this would be quite superior in the metal stack use case, at least, because we don't use like upstream Helm charts or anything like that for all these control plane components. We just wrote them for the purpose of fulfilling this values provider interface. So yeah, maybe I will just raise a pull request. I don't know if nobody responds to that, then maybe I'll just I just raise a pull request and see the reactions that are coming up then. But, yeah, if someone has an opinion, yeah, cool.
Yeah.
If someone has an opinion about it, please let me know here in the issue, and then we can figure this out if it makes sense or not. Okay, that's it.
Right. Thank you very much. So next up, there's Benedict with the dashboard usability improvements that they worked on.
Hey. Am I sharing right now?
Not for me yet. No.
Not yet. Okay. Now it should
Now.
work. Alrighty. Yeah, the dashboard usability improvements were done in 3 merge requests. First and foremost will be the one by Mark, which is like the most beautiful phrased one I've seen in a long time. Well done, Mark. It's mostly about like adding an optional, like all of those are about the dashboard. Like it's all about dashboard usability. And the first thing is to add an annotation to the project, which is the project title. This allows very long names. Currently, the project name is limited by its 10-character length, because it's used in like many more circumstances and thus limited in what it can do and what it can't. So first of all, let's cut to the issue that I'm facing. Like for me, a project name is some 10-character random generated thing, and like the object owner is something which is used to billing. So right now the projects look like this, pretty ugly. So like the idea that Mark mostly worked out is to add a project title, which is essentially a longer project name, which moves the original project name downwards to, well, make it less prominent. And it also is featured here in the, all clusters overview. And, well, that's essentially it. We are in a healthy discussion how it could be done, or like what the constraints could be. Because like the main issue is obviously that the project name is the unique identifier of a project, which makes it prone to impersonification or impersonation. And well, that's why there's a discussion. We ain't finished with that, but let's see. This is the merge request. I can also showcase the changes, but I don't think there's all too much like concrete to look at. Like it also does some beautifications in itself. The next thing is the change which tries to extend the defaults which are configurable by the operator in the dashboard. The idea there is that a lot of the configuration, the defaulting, is implicit in the code somewhere. And what this merge does is it essentially pulls all the defaults at the central place, the store config.js, and allows the user to configure them with the default dashboard configuration mechanism from my point of view. And because there isn't all too much to show, because right now I don't have the dashboard mockup running, what is configurable then is the infrastructure, which, sorting here in all these lists, sorting is something which has value, because the first entry which is available will obviously be the default. So providing these lists not only has the merit of disabling some infrastructures, but also has the merit of sorting them. For example, if I would put OpenStack first, OpenStack would be the default. Same with purposes here. Then there's a lot of single options, workerless cluster, it's a true false. It's the dashboard option you all know, which is, well, from my perspective, only really useful in development setups or very fringe use cases where you intend to only use the control plane to, well, maybe for an etcd or something. Networking type, in these options, the default, right now there's two options, obviously, Cilium and Calico. But if I would write, for example, yada yada whatever, then it wouldn't change anything. It only selects the entry if it exists. So it doesn't change anything in the discovered list form. It only allows to prefer something if there's something. That's why it's quite harmless in my eyes. Same with the floating pool, load balancer provider, high availability. It selects the true or falseness of this default checkbox and leaves the logic in place which selects zone or node high availability. I think the rest of the options are quite self-explanatory. To showcase what exactly happens is, for what I mean with implicit defaults, in a lot of these options everywhere in the dashboard, there have been defaults in place, like they are everywhere, where like the moment when an option was implemented, it made sense to put the default, then like the default was there. So essentially I'm pulling defaults from all over the place and concentrating them in like a single single store. So that's how they work. And the last change request is a merge request is the how did I phrase it? It's the ability to hide elements or the new shoot dialog. Like the maximum application of this would look like this. It would hide like quite a lot of the usual elements. For example, like the infrastructure is missing, the workerless checkbox is missing, the DNS and the high availability checkboxes are missing, or like they ain't exactly checkboxes, they are more like multi-config fields. I think that the worker has also lost a setting or two. In the maintenance, the auto update Boolean checkboxes have vanished. All of this is for 3 reasons. First of all, it's to nudge the user. So, for example, if it's not intended for users to disable auto updates in this cluster, then, well, I mean, it shouldn't be it shouldn't be this prominent option. Or the other thing is to like hide very fringe or advanced setting, like for example the workerless setting or the add-ons, which are like only really useful, or like you can only enable them in evaluation. Well, they're gone, and that's the idea. This is the simplest change. It just adds a lot of VIFs in the view files to hide the options if they're on, and uses the same store config.js mechanism to pull these options from the configuration. That's it.
Nice. Thank you very much for that. Next up is Mirza with work on the documentation revamp that they did.
Yeah, so I'm unfortunately not Mirza, but I would fill in for him since he's
so
like
he's not there.
Yes, he's like on a valid vacation.
Okay.
Yeah, but I think he will manage with me as well. So we created 3 pull requests for documentation improvements, like two improvements and 1 suggestion maybe as a draft. And the first 2 basically update the metadata that we have for our documentation and also the glossary. So we have better information on our documentation that's also then pulled in by our search. This enables the search results to become like more meaningful, as you can see here, right? In here, we basically only just matched for the title since other metadata was not available throughout the documentation. And here, after the metadata was updated, basically by Mirza, like you see, you get a lot more meaningful results. There's another improvement that he made where he suggested to also add tags and categories, which then allows you to browse the documentation from different angles, basically, right? So let's say you're looking, could have a tag for example, for an operator. So you want to see all the documentation that's just relevant for an operator, right? Then you can add those tags to your documentation entries. And since Mirza is a really smart guy, he didn't like went through all the files and added this himself, but he like created a really involved stack of different LLMs and feeding them through the documentation. So they were nice enough to update all those files for us and added the description, categories, and tags basically to every file, which is then basically used also by the search to improve the search results. And the other thing that he did is here in the glossary, you can see there's like just a lot more content, which I think is always a good thing. So you have a term and then a definition basically following it. Won't go into too much detail, but I think the more things that you can look up, the better it is from a perspective. The other thing that we did is what we found out while working with the documentation is that it's since we having multiple deployments for the documentation, it's a really involved process in getting it working locally, which is understandable, but I think at least from a developer perspective, right, and also as a contributor's perspective, it's really hard to since you usually not too much like on fire for documentation anyways, then doing the extra effort and spending a day getting the documentation working locally is nothing that you really want to do. So we created a pull request, like showcasing a different framework that could be used to like documentation. And to show you how simple it is, I would quickly once do it locally. So here is my terminal, and let's just I'm cloning just a repository. Takes 1 second. Moving into the directory, doing a checkout for the branch, doing an npm install. And now, right, you may be saying, oh, okay, I don't have Node on my system. That's totally fine, right? This could also be wrapped in a Docker container. But just to showcase you how simple this is. There we go. And now we're up and running, right? Took us less than 10 seconds to get the documentation running locally. Also has like a little bit more modern UI to it. This one is obviously not fully finished and fully fleshed out, but I think it shows it nice. It shows like how this could be handled, and I think especially as a contributor, that's what I would be loved to work with. Also here you have like couple of different options to work with the search, right? So just out of the box, what you're getting is like this here, but there's also obviously a way to showcase a preview and to tie in with different search engines like Algolia, or I think there are a couple of more ones that you can use. Then when you go onto documentation, right, it works like you would expect it to work, right? It showcases all the things. You have a button to edit it directly on GitHub. So if you click there now, right, you immediately open the file in GitHub and could like open the PR if you want to, be like, hey there, I would like to change this. Yeah. So what are the next steps for us? The next steps for us would be one that Mirza proposed is to look more into how we could improve the search results and our like data that we provide to the search engine so that we make the search and results that we provide more meaningful. He suggested this could be like a nice student project, which he could mentor in the future. So he has a couple of students per year that he's supporting. And he suggested this could like be a topic for that. But one thing that we're really lacking at the moment is having analytics on our documentation, because if we do an improvement, we don't really know if it is better or not, because we just don't know how many users do we have on our documentations, how much time they're spent on that, right? Are they frustrated when they like go and search something, right? And then in the end go through the browse through the structure anyway, right? Because they didn't just find with search what they looked for. So analytics here would help us a lot. That's what we could be looking into. And then for this improved version, we talked to Victor, who's like the mastermind at behind our current documentation, and we created a pull request. Let's see how technical issues arise there, maybe with this like multi-deployment of documentation that we're currently having. But he's looking into this, and I think we will keep you posted. Yeah, that's it from my side.
All right, thank you very much. Next up is Gerrit again with exposing EgressCIDRs in the shoot info config map.
All right, let's just hope my notebook does it again. Maybe just wait again.
Yes, it does it again.
Okay, cool.
Lucky day.
Yeah. Yeah, this is a really small one. I guess this was considered a fast track as well and was implemented in the course of an evening or something. Yeah, it's yeah, some of you might know that there's like small config map in the kube system namespace of every Gardener shoot, and Gardener puts some, yeah, like metadata information about the shoot inside this config map, such that you don't need access to the Gardener API to yeah, get to know this information. And yeah, there are some controllers which are interested in the EgressCIDRs, which are pretty new in the shoot spec. And yeah, the idea was just to also put this into the shoot info as well. And yeah, this, as I said, quite a small one. So yeah, how can I show it here? I think on the bottom I have the shoot cube client. And yeah, here's the config map. And in there we now have the EgressCIDRs as well. So same way as the node pod networks. When there are multiple CIDRs, it will just be comma separated there. Yeah, and this is basically just copied from the shoot and also already got merged. Quite a small one, but nice. That's it.
Nice. Thank you very much for that as well. Next up is Konstantinos with overcoming the maximum of 450 nodes on Azure. I think you're currently muted or something. Yeah, you're muted.
Can you see my screen?
Yes, I can see your screen.
Okay. So I will present definitely my work only and not Johan's work at all in this. Definitely was all me. Okay. So let me give you an explanation. Actually, I spent a couple of minutes before the meeting, and let me impress you with my diagram. Okay. So the preface is that Gardener supports clusters in Azure. However, the clusters we support in Azure, they don't support overlay. That's a limitation because Azure does not support IP in IP. And for this reason, currently in Azure, we don't support any overlay setup. And that forces us to use route tables. And in the screen, you should see what our current setup in Azure looks like, right? So assuming that you have kind of like a like you have your typical pod, the node subnet somewhere on the side, and your setup currently would look like you have a resource group, you have a VNet, you have a subnet. That VNet that is where your worker resides. So it typically matches the range of the node seeder. And then you create VMs. The VMs, they have a NIC in that subnet. And then for each of these VMs, you need to assign which kind of pod range they are handling or they assign to them. And you do that through a route table. So for each node that you create, then there is an entry in the route table, which marks the pod range that they assign that they are assigned to the nodes. However, this presents a limitation currently because the route tables in Azure, they can fit up to 400 or 450 nodes. And like, frankly, this is a limitation that we will hit very soon, actually. Like, the clusters are getting bigger, and we want to find an alternative way to deal with that issue. And so we tried a couple of things, and then we came into the following setup, right? What you see here is basically, so what we try to do is avoid the usage of any route tables, but we need still to have some kind of routing to the pod seeder. So the idea is basically to create a secondary subnet in the VNet that matches the your pod ranges and kind of have a secondary NIC basically that have a secondary NIC from the pod range, which will handle all the your pod range for that node basically, and that should kind of make it so that we don't need any more route tables and therefore have no limitation. So you get kind of like native routing. So yeah, this is a little bit of a ongoing research topic because we hit some limitations. So we try to do things or like try to set up a cluster manually. but we hit some additional limitation. Basically, the routing in the nodes with the two NICs did not work very well. It did not work as expected. So we are still planning to troubleshoot that. And also we depend on one more feature, which is, or at least we would like to have it, which is a preview in Azure. And we ask to get access to that feature. So what happens currently in Azure is basically that you cannot really assign range to the NICs. You can only assign single IPs. And this is kind of like also what AKS is using, right? So like for any given pod seed range, you would need to assign all the IPs one by one. Which I thought it was a little bit tedious. So we wait for that feature, and then the plan is to try again once we have that. What our conclusions were is that it could be that making work with two NICs is maybe hard, but like this is the preferable option because this is the easier option for current suits also to migrate, right? So like assuming that we can get this to work, and then the plan would be to try to get existing to migrate within the limitation that what it means to have a second pod subnet in the same VNet. But we would like to have a migration path, but this may also be proven more difficult, as I said, because of the routing issue in the nodes. What AKS is doing in comparison is it has one big subnet where both nodes and pods get assigned the ranges. And this can definitely work from a routing perspective, but of course you need, we may need to consider more components to do IPAM and so on and so forth. So it's something that it will be a second option, but it can work for sure. Okay. And that were the conclusions. So the next steps is basically to wait until we get our access to the preview feature and then try to set up experimental setup again. Kind of.
Nice.
Now
Thank
say
you very
that
much.
this is overall, just cool. I think this is overall very interesting because for the IPv6 for DCP, we use similar techniques. I think like it can work. Yeah, it would be nice. I think like this is particular to Azure and limitations for Azure, but this whole setup of the secondary pod subnet in the same network and so on, like it's an idea that we will probably see again in other places. Just that.
Nice.
Okay.
Thank you also very much for that.
And thank you, Johannes, for all the work. Yeah.
Yeah, I think he's currently on vacation, right? Next up, there's multiple parallel versions in a Gardener landscape, presented by Eric. Yeah.
Hey.
Hi.
Let me kick things off by sharing my screen. I brought a small demo. Great that my Mac is lagging when I start the screen share. So I was looking into bringing multiple or different extension versions to different seats. This would be super useful for us because we like to try new versions on a dedicated set of seats and then promote them, these versions step by step through our landscape. I learned that on the controller registration resource, let's get this one. There is actually already a feature in under Spectre deployment, which is a seat selector. And there we can basically specify which seats are allowed to run the extension. And also we have in the registration, we have these deployments linked. And if we bring like a registration with two different label selectors for the same resource, but with a different deployment ref, we can basically already differentiate between different seed clusters and bring a different version to them. So if you check the selector resource here, we have the label selector foobar here, and the other one is foobus. Yeah, and then we also have two different controller deployments. In this statement, we have both. They're very similar. The only thing that's different is that the second one is basically specifying an image tag, which doesn't exist. And if we now check the seeds, I guess -l foo, we can see that the local seed is labeled with the foo bus label and the other one with foo bar. And the foo bus seed has a working set of values. So if we take a look in the extension namespace here, we have a healthy extension. And if we go into the second seed, we should see that it's broken, but it shows that different extension version basically was applied. What's also quite nice is that seeds can be relabeled, which in turn should trigger an uninstallment and a reinstallment. And from my testing, at least with the local provider, also shoots survives this. So if we do this, we should eventually, the pods are gone now, and the namespace should also be deleted soon. And we even already got the new one, which hopefully should contain the pods. Yeah, this is working quite nicely actually. So if you would label seeds which like whatever alpha, beta, and prod, different versions can be transported this way. There's one limitation right now currently on controller registrations. On the different resources, there's currently a Boolean field, which is called primary, which can be true or false. And this seed selectors, you can't specify seed selectors right now if primary is set to true, which also is the default. But this primary field is only used in validations. And I think it was introduced somewhere in 2020, so already 5 years old. So for this to work out properly, we would need to have a discussion around what we want to do with that field, if it's still necessary or useful. That would be the follow-up. And otherwise, there are some limitations to this approach. It doesn't deal with admission webhooks in the runtime cluster, and it also doesn't take care of gardenlets. Yeah, all right. That's what I wanted to show.
Nice. Thank you very much. Next up, there's the worker group node rollout by Radu.
Hopefully you can see me, see the screen.
Yes.
So the worker group node rollout, basically the idea there, we worked with Gerrit and Jeremy. The whole idea is that we want shoot owners to have a way to manually trigger a worker pool rollout. And the approach that we decided on was to basically allow an annotation to be added to the shoot where you can specify which worker pools you want to be manually rolled out. In this demo, I've created 2 worker pools, so one called local and one called additional. Whole idea is that you just add the annotation. This adds a status to the shoot called manual worker pool rollout. And this status basically shows a history of what's happening. And the other part of the implementation is when you actually set the annotation, how does the provider actually get to know that it has to trigger a manual worker pool rollout? And the implementation there was to create a change into the hash function that it uses to calculate the name of the machine class and the machine deployment. You can see that actually it already triggered the manual rollout. So what happens is basically the annotation is added. This status gets added to the chute. And when the provider needs to calculate the hash, it takes into account this last initiation time. This causes the hash to be different from the previous hash, which triggers the actual mentioned worker pool rollout, since the new hash is different from the previous one. And yeah, that's about it. There's an ongoing discussion whether this approach is maybe more complicated than needed, since one thing that can be done is just when the annotation is set during the chute reconciliation flow, just manually find the machine deployment that corresponds to this worker pool, and then just add an annotation to the spec template that's used for creating the machine set. But we'll see what happens with that discussion. There are some pros and cons to both approaches. And yeah, that's about it.
Nice. Next up, last but not least, we have Konstantinos again with the instance scheduled events watcher topic.
Yeah, long time no see. Okay. I know it's the best topic for last. Let's go. So, okay, then let me again share my screen. Okay, so then maybe let's do a brief introduction to the scheduled events. So, I mean, the scheduled event is basically a channel that the cloud provider offers so that you get subscribed to events that may happen to your VMs. What are event VMs? I don't know. There are like a lot of things, and each cloud provider defines their own. But on a rough description, it's maintenance events or notification if something went wrong to the actual hardware. Your VM needs to be migrated, and so on. Your VM needs to be rebooted, and so on and so forth, right? So there are basically a couple of events that happen due to physical limitations in the actual world that translate to events for your VM, and this is just a channel that you can get these events for. Like as part of the task, we compared various ways on how we could get access to the events. One common way that all cloud providers they do support is access through the instance metadata. And what the instance metadata is basically just a service that you can query from inside your VM. But you can, the VM can learn information about itself basically, right? So like its name, its like things about its network, but also can query about the events. Let's see what we did. We actually opened an upstream pull request, if I find it. Yeah, actually we opened an upstream issue and an upstream pull request that implements this for Azure. This is a little bit special again for the Azure because from the Cloud Controller Manager perspective, Azure is the only one that runs a daemon set on the data plane of this. So like for each node inside, there is a daemon set that implements a node interface. Usually the node interface of the cloud provider is implemented in a controller, but for Azure, it's a daemon set. So we decided that we will modify that and use it as a way that we can create the events of the node and then expose that. What this ends up doing is basically adds a node condition, right? So that it's something that can be, and also an event from the daemon set, so that it actually can be picked up by observability means, and then you can use it to, see if there are any node events. So, and also we have a demo, which, let me just a second prepare. So, what would you see now? I hope it's big enough so everyone to see. So, I'm in a suite cluster in Azure. You can see that I have like 2 nodes here. And if I go to my kube system namespace and I go for the pods, then you can see the Cloud Node Manager. This is the daemon set that I was talking about. And now what I will try to do is I will try to trigger an event. So I'll go to one of these nodes and schedule a reboot. Why a reboot? Because the reboots, they do not happen instantaneously, and actually they are scheduled within 15 minutes if you don't make any other modifications. So we should see that if I do a kubectl get node, monitor YAML, and I got the conditions, then this is a condition that we added. If there is nothing, then you see something like no scheduled events and false. And hopefully, soon. We should actually see that. Let's wait for that. And in the meantime, I will give it 1 minute. I'll talk about also the other approach. So I think this is a very interesting topic, and we hit a couple of crossroads with regards to how we want to gather the events and how we want to expose the data. Like if we take a look at GCP and AWS, for example, they give you a way to query the events through the API. And so far, Azure is the only one that only allows you access to the metadata instance service. But because because all the cloud providers, they do support the instant metadata service, we think that it's either actually have an implementation that can work like similar to a daemon set, or the much better approach that we considered was enhancing the guard and the node agent, and so on and so forth, so that we can actually query the events. I mean, again, Azure is a special case that we have the daemon set there. We can also implement any daemon set for the other cloud providers. But yeah, we will decide on that one. And also, surprisingly, I think it's a very nice, you can see that here. So this is what the schedule event looks like. We have the transition, we have the event has an ID. About it tells you kind of like, sometimes it gives you an estimate how much the downtime would be. Here it's -1 because it doesn't know. And it also gives you the description that the virtual machine is going to be restarted as requested by the authorized user. And when the node restarts, then the event is done, will no longer be. So then when the daemon set runs again, then we will make the conditions should clear out. Although this will take like 15 minutes, so I don't think we will wait long enough to do it. But you can trust my word for that. But in general, I think it's also very interesting because this can fit for pretty much every cloud provider upstream, and also kind of neatly integrates with existing monitoring tools, right? So this could as well be something that gets implemented into the other cloud controllers managers, and even in their controller mode, right? So like, because you don't need a daemon set to query this information, we can just open upstream PRs for pretty much everything. So far, we wait for the Azure community to, like rate our idea basically, and then we can finish the PR. Currently, it's in draft mode and it's just missing tests, but I mean, I think I will add them, but it's just that we need the buy-in from the community. And that would be it. If you have any comments, or if you have any ideas how this condition should look like, or how we can make it more actionable, I think like one parenthesis is that the conditions in sometimes in certain cloud providers, they're actionable, right? So you can, for example, have something like annotate the node with something and then accept the event, and the acceptance of the event will just make it trigger sooner. Currently, you can only observe that. If you're a stakeholder or a user and you don't want your node to be restarted randomly and you want to do it basically in your own control way, you would need to do some kind of manual operation, which would be to SSH into the node and accept the event. But we can also automate that through annotations and so on and so forth. So like, I think generally like there are a lot of improvements that you can do. And we just need to see what fits upstream, what fits in Gardener only. And yeah, that's it. Any questions?
All right. Thank you very
Okay.
much. And as Rafael said in the beginning, I mean, if you have any questions or want to give feedback, most of it is, I mean, all of the PRs and everything that is done, and the people who worked on it is referenced in the hackathon document. There will be some update to it regarding the achievements that have been done. And yeah, with that, I thank you very much for all of the presentations and all of the demos and everything that was done around the hackathon as well. And it was great fun also to see what everything has been done. A lot of progress, a lot of good progress. I mean, everything was good progress. And with that being said, I want to give you these 12 minutes that we have saved back to you. And thank you very much. And I hope you have a wonderful day. Bye-bye.
Bye-bye. Thank you. Bye-bye.
Bye-bye.
Thanks. Bye.